Coming to the third problem. In this video, I am going to explain about the third problem, third example sum. Example 3. A transparent which is made up of glass, a transparent material which is made up of glass. So a sphere which is made up of glass material and it is a transparent material has a small opaque dot at its center. Does the apparent portion of the dot appear to be the same as its actual position when observed from outside? Here, what are given and what we have to find out. Here, a transparent glass sphere. So, first you have to draw a transparent glass sphere. So, this is a sphere. Has a small opaque dot at its center. Suppose if it has a dot at its center, does the apparent portion of the dot appear to be the same as its actual position when observed from outside? Suppose from the sphere, at what distance the sphere, this dot is located, or otherwise from this dot to the sphere. Otherwise, wait, let me explain. So a dot is located at the center of this sphere, but this dot, when you observe from the outside of the sphere in any direction, does this dot appears at the same position? Means suppose if I observe like this position, this dot appears for me and at this place or not? Will the dot appears at this place or not? You have to find. Suppose if you are watching like this, so at this position at the same place, or if you observe, will you get at the same place? If you observe like this, will you get at the same place? Means at the same place will you get this dot or not? That you have to find out. Means the image you have to find out here. What you have to find out here in this problem? Image of this dot. Actually the dot is at the center of the sphere. You have to find out the image. You have to find out the image of this dot same as its actual position when observed from the outside. When you observe from the outside, how does this dot appears, at where it appears? That image you have to find out. So for this, again, this sphere has a curved surface. Again, we have to follow the refraction of light at a curved surface. And here we have to find out for the refraction of light. Refraction of light at curved surface. What is that formula? N2 by V minus N1 by U is equals to N2 minus N1 by R. Now we'll find out all these values from the figure. We'll substitute in that and we'll find out what is V value. So for this, we'll find out N1, N2, what is V, what is U, what is R. So we'll find out all these values. Here the dot is in the sphere. So the light ray travels from the glass medium to here, glass medium to here, air medium. So this glass medium is N1 and for air medium the refractive index values you have to take it as N2. Because where the object from that the incident rays along which directions they are traveling, that you have to find out. Here the dot is in the glass medium and the light is traveling from the dot to air medium, glass medium to the air medium. So first this refractive index of glass value you have to take. So the refractive index of glass we don't know. So here N1 is the refractive index of glass. So that value will take it as N. We don't know. So just we'll take it as N. And N2, this is the refractive index of air. So here N2 is the refractive index of air, that is equals to 1. Refractive index of air is 1. And V means we have to find out here in the problem. When you see that dot from the outside, so where does it looks, how does does the apparent position of the dot appears to be the same? So that is our question. So V you must find it. So V is equals to, we'll take it as V1 because we don't know, we have to find out that. Now U, object, where it places this object at the center of the sphere, that dot. So from that dot when you join, so this is equals to radius of curvature of the sphere. So you must take it as R, and the radius of curvature also R only. And we'll find out these values because this we don't know. So no need to take the sign convention for V, and we have to take the sign conventions for U and R. And here U means the light ray is traveling along this direction, but you must find at this pole, what is that? Not pole, optic center. So you must find out along this direction. So for that this U becomes negative, and for R also we will take like this direction, but you have to measure like this. So you have to take R is also negative. Clear it, children? Now we will substitute these values in the formula. Now N2 means 1 by V means we have to find out minus N1 means N by U means how much? Minus R is equals to N2 1 minus N by here minus R. Okay, now we have to find out what is V value. So for this just we'll simplify. Minus into minus, it becomes plus N by R. Here the negative value is down, so we will multiply with minus. Both here minus and minus, just we will multiply with minus. When you multiply with the minus, you will get minus 1, minus into minus plus N by this minus into minus plus R. Clear it, this one. Just both the numerators and denominators, just you multiply with the minus symbol. Then you want V value, so you send this value to another side. Then 1 by V is equals to, here already what is there? Minus 1 plus N by R. And this plus, when it goes to another side, becomes minus N by R. Then here R and R both are same. So when denominators are same, just otherwise I'll write here 1 by V is equals to this is R. Then when you take numerators, minus 1 plus R, and this is minus R. Then plus R minus R both will cancel, and here you are getting minus 1 by R. So here 1 by V is equals to minus 1 by R. So reverse it. When you reverse it, you will get V is equals to minus R. V is equals to minus R. So you will get the image at the same radius of curvature only. Means you will get the dot at the radius of curvature, and here the negative symbol indicates. So this is the light direction, and you are finding the image like this direction, then you will get the image is negative. So you will get the image at minus R. This is the third problem.